It's more of a distributed framework where data is actually processed close to the applications or processed close to the originating data source. So there are some key reasons to adopt edge strategy, which are to support IoT, modern application requirements, improve performance, security, and reliability. And just like the cloud and the definition of the cloud and how people use the cloud is different for every single company, this is going to be true for the edge also. The way you utilize the edge or the applications that may require this type of technology may be different for every single company out there. This is also relevant in the current COVID environment because we have a distributed amount of resources and people that are working from many different locations. So the way that we think about application disbursement and where we deploy infrastructure may change if this continues for the long term. So our goal is going to be to show you how edge computing can bring value and a competitive advantage to your business.
First, we start seeing that our data centers are going to profoundly change. And by 2023, we're expected to have about 39,000 core data centers. And I've seen numbers range anywhere between 35 billion and 50 billion devices, just things out there on the internet generating data. And that's by 2022. So that number is almost here where we're at now. And so that's going to start changing how people design their data centers, but also really how they build their applications. What we see here is these applications really require low latency. Milliseconds can matter in a lot of things, in sporting events, in healthcare. And so as a result of that, we've seen a huge growth in edge locations. And what we're expecting to see by 2023 is 7 million edge locations. But interesting is by 2022, we're expecting to see half of enterprises' data being generated at the edge. What that means is that data, which adds value to the organization, we're seeing half of it distributed to the edge, which is a new model for them.
And the last example we'll look at here is oil and gas. So oil and gas, is already a unique business, has many different edge requirements. They could have hundreds, thousands of small remote locations, rigs, seismic vessels, and most of these sites, potentially could have either low bandwidth or high latency WAN connections, could be some type of satellite connection. But imagine if these companies that are capturing all of this data had the ability in real time to analyze that data, give themselves a competitive edge over their other competitors, copy that data back to some type of cloud or centralized data center longer term. From that trending information, we can provide business information, analysis, forecasting capabilities. And then one of the things is on these types of sites, you could have 70 different OEMs or vendor type equipment out there. So we want to reduce that complexity, utilize IoT to bring all that data into a single management interface and make that data more accessible, make it more relevant to the people that are viewing it. And with that data, we can improve the environmental impact. Identifying leaks, identifying issues ahead of time is going to help reduce the financial impact, potentially environmental impact, reputational damage for that customer. And then improve safety. Because we can predict and detect those leaks, we can reduce the risk of explosion, protect our assets, reduce fines, and ultimately edge and IoT technology would be able to save lives. So if you look at the bottom, let's just take this little autonomous car example, and let's pretend that that's one of your remote locations. This car, houses many, hundreds or thousands of sensors, many different devices, just like your remote site. This could be some type of offshore boat or rig or any type of location that you have. All these sensors are gathering data. And what are my options at the current time are really to send that data out to the cloud or a central data center. And in the case of a autonomous car, I can't wait for the response from the cloud. If the car is driving and it needs to make turn or stopping instructions, or it needs to make decisions around that data, I can't wait for the cloud to respond to me, and I can't risk the potential of that link going down. So I need to place some type of compute power local to that vehicle or that car or your remote site. That could be on the site. It could be in a localized data center. It could even be regional, potentially, depending on the type of latency and the response that you could get from those sites. So what I want to do here is just have you think about how that reduced latency, real-time analytics, or action response could give your company a competitive advantage. And that's where we can help. We can help you with the design, the consulting, and the procurement of all of these different items.